Welcome to Untitled Maths. In this video we're going to have a look at some questions involving geometric progressions. The difference between geometric progressions and other sequences is that you multiply when you go from one term to the next. With arithmetic sequences you add or subtract. With geometric progressions you can you can multiply or divide. So each number you multiply by the same number and that gets you the next term and so on. Now the number you multiply by to get from one term to the next is called the common ratio. And to find the common ratio, what you need to do is you need to divide a number by the previous number. So for example, in this one we can do 10 divided by 5, which is equal to 2. 2 is our common ratio. And you can see if you do 80 divided by 40, that's 2. If you do 40 divided by 20, that's 2. So it doesn't matter which numbers, as long as you pick two consecutive numbers, it doesn't matter which ones you pick. Part B says find the 10th term of the sequence. So we can do this by just keeping on timesing by 2 until we get to the 10th term. And if you wanted to type it in your calculator as one sum, you would need to type in 5 times, and this is where some people make the mistake, they put 2 to the power of 10. It's actually 2 to the power of 9. Because if you think about it, to get to the second term, you times by 2 once if you want the second term. If you want the third term, you need to times by 2 twice. If you want the fourth term, we times by the 2 3 times. And if we want the fifth term, we times by 2 4 times. So you need to be careful of that. So it's sort of like 2 times 2, n minus 1. So in this case, it's 5 times 2, and then the number of terms take away 1. So therefore, if you're trying to find the 10th term, you do 10 take away 1, which would be to the power 9. Let's say you were trying to find the 20th term, it'd be 20 take away 1, which would be to 5 times 2 to the power of 19. So if you put this in your calculator, 5 times 2 to the power of 9 is 2,560. Let's have a look at a bit of a harder one. So the first 5 terms of a sequence, so this one's working with decimals. Finding the common ratio is exactly the same. You just do 0.75 divided by 0.25. You don't have to choose those two. You could choose another two if you want, but usually the first two are the easiest to pick. And that's 3. So we know that each time to get a new term, we need to multiply by 3. Part B says explain whether 55.5 is a term in a sequence. Well, it's not. And the reason you know it's not is have a look at the sequence. If you look at the sequence carefully, you can see that it alternates between 25, ending in 0.25 and ending in 0.75. And 55.5 ends in 0.5. So you'd probably write it a bit more explanation out, but ends in 0.5. So because 55.5 doesn't end in 2.25 or 0.75, you know it can't possibly be in that sequence. And quite often, that's quite common in geometric sequences. You'll see sometimes they end in similar numbers, depending on what you're multiplying by. So do watch out for that. And for the last question, instead of giving us the sequence, they've actually told us what the first term is and have told us what the common ratio is. And the way you'd work out this, well, if we know it asks us to write down the first 5 terms. Well, from the geometric progression they've given us, we know it's told us the first term is 1.5. And then to get every subsequent term, you must multiply by 5. Probably the best way to do it would be put 1.5 in your calculator, press equals for the answer, and just put answer times answer times 5, and keep on pressing equals to get every subsequent term. So you get 7.5 times 7.5 by 5, you get 37.5. Then you'd get 187.5. You can see these get big very fast. And 937.5. And if you do have a common ratio of something like 5, you will see it increase quite rapidly. And the last part B is find the 10th term of the sequence, give your answer to 3 significant figures, and in standard form. So like we did in the first question, we're going to need to do 1.5, the first term, times 5. And if you remember, we have to take 1 off the term number to find out. So we're going to have to times by 5 9 times. And if you put that in your calculator, what you'll get is you'll get 292. 2,929,688. But if you look at what they asked us to give it in, they want it to 3 significant figures and in standard form. So we need to get it to 3 significant figures. So that's 292. So it'd be 2.9. We'd need to round the 2 up because of the 9 there. So it'd be 2.93. And they want us to put it in standard form. So if we see how far, 1, 2, 3, 4, 5, 6. So yeah, whatever you do, you can count the number of places a 2 moves, or you can count the number of numbers after the 2, and that's 6. So that means it'll be 2.93 times 10 to the power of 6. If you need to I do have a video on standard form if you need to recap that. Right, thank you for watching. I hope you found it helpful. If you liked the video and like to see more, please click the subscribe button. And for practice questions, please visit my website www.mitchellmathandscience.com. The link can be found in the description.